Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me for yet another video in our Rust programming tutorial series. If you're not already, make sure that you follow along with the playlist on my YouTube channel for Rust programming tutorial, and make sure that you check back there on a regular basis for any new videos. The topic that we're going to be covering in this particular video is how to implement an HTTP client into your Rust application. There's a variety of different crates that are available, which are dependencies that you can basically just import into your Rust application. And then you can just simply plug into these libraries in order to use the functionality that they provide in order to send HTTP requests. Now, the library that we're going to be using in this particular case is the crate called Reqwest with a W here, but there's actually quite a few other libraries. For example, there is curl-rust, which is a binding to the libcurl, which is, I believe, written in C or C++. So you can use this to just kind of wrap that functionality. There's also this hyper crate over here. And what's actually interesting is that the request library is built on top of hyper. So if you were to look at the dependencies in cargo.toml for the request crate, you would actually see hyper as a dependency. Now, it seems to me that the same guy, this Sean MacArthur person, seems to have created both of these projects. And so Hyper is designed to be more of a low-level library for Rust, but the request library is a little bit of a higher level module that most people are going to be most likely using versus the low-level Hyper library. Another option you have is called urec over here. This is a HTTP client, and it only supports blocking I/O. And so it doesn't support asynchronous I/O. That helps keep the library simple, and it keeps the dependencies on it to a minimum. So if you only care about having blocking I/O and you don't necessarily care about having access to asynchronous HTTP operations, then the urec crate might be a good one for you to use. Now, we're not going to be getting into asynchronous stuff. I don't want to overcomplicate HTTP stuff, for especially anybody who's new to the Rust programming language or just programming in general. So we're actually going to be using request in a synchronous fashion, or what's known as a blocking fashion, rather than using asynchronous functionality. I'm planning on talking about asynchronous concepts in a separate video that goes far above and beyond just using HTTP. It can extend to many other types of things as well that can be long-running operations. So we'll just focus on the blocking I/O for the time being. Now, one other tool that I wanted to bring your attention to is this utility. It's a graphical tool that's cross-platform. It's open source as well, and it's called Macoon. And this is a really nice utility that allows you to mock APIs. So if you need to build a Rust HTTP client, but you don't necessarily have access to a backend API, you can actually just use this graphical tool in order to spin up an API locally, and then you can test against the mock API locally. And then when you're ready to switch over to a production API, you can go ahead and just switch your DNS endpoint to point to that alternative API. So this is a really nice tool, and I'm going to be using this in order to incorporate certain HTTP features like redirects, for example. If you want to do a HTTP 301 response and permanently redirect and then have your Rust HTTP client follow a certain number of redirects or completely reject any HTTP redirects, then we can set things like that up in Macoon here as well. So feel free to download the latest release of Macoon for your operating system. It does support many different packaging formats here. For Linux, you've got AppImage, Debian packages, RPM packages, Snap packages. On the Windows platform, they have a portable package that you can install with the Scoop Package Manager. They have an Apex package as well, if that's your thing. And they also have DMG packages for the Mac OS operating system if you're on a Mac. All right, so before we actually jump in and start writing some code, I just wanted to let you know that I am an independent content creator. So any kind of support that you can lend to my channel is extremely meaningful to me to help me grow this community around Rust and many other programming concepts. So please head to my channel at youtube.com/Trevor Sullivan, hit the subscribe button so you get notified about new videos, and click the bell icon next to the subscribe button. That helps to ensure that the YouTube application is going to send you notifications when videos are released least on my channel. Also, if you go to the main page on my channel, we do have a playlist right here called Rust Programming Tutorial, and this is going to follow all of the different Rust programming concepts that we are learning about. Currently, there are 23 videos in here, but there's a lot more to come, such as this video, which is going to be video number 24. All right, so let's go ahead and talk about how to use this request crate. So what we're going to do is go under modules here, and you'll notice that one of the child modules that is exported by the request crate is this blocking module here. Now, if you want to use request as your HTTP client library in Rust, then the default is going to be asynchronous operations, and you're going to be working with what are called futures, which are kind of like promises in JavaScript, where it's basically a lazily evaluated kind of pointer to a function call that can happen sometime in the future. And so when you actually invoke that future, then you can get the response back from that future. But that adds a lot of complexity to our application. So we're going to be going into this blocking child module, and this is what's going to allow us to do synchronous operations so that we can sequentially step through our code and more easily understand what's going on without having the asynchronous code in our program. So anytime that we are going to call functions, we need to make sure that we're going into the blocking module here under request. If you're using the types that are in the root of the request crate, then that is going to be the asynchronous functionality. So what we're going to do is install this crate into our application. We'll create a brand new application from scratch. We'll use the Cargo CLI to add this crate into our project, and then we'll take a look at how to actually use some of its functionality. One thing that I'll note is that the documentation is really good for this project, and under optional features here, it does talk about some of the different optional cargo features that you can install. And believe it or not, the blocking feature is actually optional in this crate. So when you do cargo add to add request to your project, you'll need to make sure that you explicitly enable the blocking feature for the request crate. So let's go ahead and take a look at this now. So I'm going to head over to my VS Code window right here, and we're going to create a new project. You may also have noticed that I've got Makun running right here, where we can create additional routes on our kind of mock API server here. So we'll talk about that in a few moments once we actually start making HTTP calls. But for now, I'm going to go ahead and just create a project directory on my Linux server called, how about HTTP client? And then we'll go ahead and open up that directory in our VS Code editor. Now, I've got a video back in my playlist. In the very first video, we actually talked about setting up the Rust toolchain on a remote Linux server. So I'm actually using VS Code on Windows, but I'm writing Rust code remotely on my Linux box. So what I'm going to do is say cargo init inside of my project directory here. Of course, we don't have any dependencies because this is a brand new scaffolded project. So what we're going to do is say cargo add request, and when we install request, you'll see it just installs the latest version here, but it doesn't specify any features. And if we look through the feature list here, you can see that little red minus sign next to blocking means that the blocking API is not installed by default. So we need to do a cargo add request and then say features equals blocking, and that'll make sure that the blocking feature has been activated for the request library. So now if we just scroll up in our feature list here, we should see a little blue plus sign next to the blocking feature. Great. So now that we've got our request library imported, we can go ahead and start writing some code in our main.rs file here. So let's just get rid of the print line hello world here, and we'll go ahead and start by doing a use request, and then we'll say double colon and then blocking. And then we're going to wait for the Rust analyzer here to kind of finish indexing all the libraries so that we get auto completion. So generally it works pretty quickly in a few seconds. And now you can see that we've got a bunch of data structures that we can instantiate here called a client. That's an HTTP client. If we need to customize the HTTP client, we can use the client builder as well. We also have the ability to construct a request using the request struct directly, or we can use this request builder to chain some different methods together to customize things like message bodies and headers and other things that go along with working with HTTP requests. All right, so what you're going to see for starters is that we can just call a get function here. So if all you need to do is just call a really quick get request, then you can just use the get function here. But if you need to do anything more advanced, then you'll need to construct a client. So we're going to go ahead and use the client object here, and then we can instantiate a brand new client from this type here. Also, we do have the ability to use the client builder. So if we want to, we could say client and client builder, and both of these will kind of allow us to construct either a basic client or a slightly more complex client. All right, so let's just do a quick cargo build here to make sure all of our dependencies are built. And it looks like something is running in the background. So let me just see what's going on here. If we check out the Rust analyzer logs here, it does mention that we need to install libssl-dev. And I did install this on one of my other virtual machines, but I don't think I installed it on this one. So let's just do a quick apt install on that particular package and make sure that resolves our issues. I think that has to do with the TLS support for the HTTP client. So I'm just going to go ahead and install that, and then we'll reload our window, which hopefully should reinitialize everything and get everything working with Rust Analyzer. All right, so I also had to install the package config package right here. So as soon as I installed that and reloaded the VS Code window again, the Rust Analyzer stopped complaining down there. So now we should be able to come in here and do a client. And as you can see, the client has a few different functions available on it, like get, head. We've got post, put, patch, delete, and so on and so forth. So we can use all of those helper functions in order to just send a really simple request. But again, if we need to do anything more complex, then we can use the client builder in order to construct a client as well. So for now, we'll just say client and then get, and then we need to specify a URL that we want to retrieve using this client. So what we'll do is go ahead and construct a new HTTP client. So we'll use this new function right here, and that'll create this client object that we can then use to call those methods. So what we'll do is assign that to a variable like HTTP client. And then after we have the client, then we can actually use those functions on the instance of the client, or we could pass in a reference to the client if we want to use the static method version of the get, head, patch, put, post, delete, etc. All right, so now what we need to do is plug in a URL that we want to retrieve. So for example, let's say that maybe I want to retrieve HTTPS trevorsullivan.net. And then this is going to return a result back to us. So we'll say let HTTP result. And again, you can use whatever value you want for these variable names, but I'm just kind of giving them kind of self-explanatory names that should make sense to anybody who's reading the code here. So as you can see, the get function here actually returns back a request builder. It doesn't actually send the request to the remote server. In order to actually send the request, we have to do a .send operation, and that's what's going to give us the result here. And the result is just going to handle either errors if some kind of error occurs, like a DNS resolution error or a TCP connection error if it's listening on the wrong port or something like that. And then if we do get a positive response, then that'll be in this response here. So that's a pretty standard pattern that we see with a lot of other Rust APIs. So we'll go ahead and get the result from the send operation here, which again is going to be a synchronous operation. It's not going to do async here. And then we'll just check to see if this result is okay or if it has an error. So we'll say if the HTTP result dot is okay, then we'll go ahead and just print out the results. We'll just do a debug pretty print here with colon hash question mark. And then we'll pass in HTTP result dot okay dot unwrap. All right. So that'll give us basic access to this response object here. And then if we want to grab specific information like headers or cookies or the message body or anything from that response, we can do that separately. So down here, we'll say cargo run and see what we get back. As you can see, a bunch of dependencies are being compiled here, things like Tokyo, which is used for asynchronous. We've got the HTTP package right down here as well. We've got TLS packages and things like that. And then the other thing you're going to notice here is that Hyper is being compiled as well, again, because Hyper is a dependency for the Reqwest project. So right down here, you can see that we've got an HTTP response being printed out with all of the various fields defined on it. So we've got the URL that was requested, we've got the DNS name of the URL, the path of the URL, the query string, if applicable, the port number, if applicable, and things like that. And then we've also got a list of headers down here that are sent back from the server back to the client. So we can see that the service is running on Vercel, which is a web host. There's a whole bunch of other parameters on here as well, or headers, I should say. So feel free to inspect those a little bit further. So let's say, for example, that we wanted to get the message body. So I'll just plug in a prefix here that says body so that we can see that in our output. And then we're going to go into this response object, and we can call a function here like .bytes. This will get the response body as bytes, or there's another helper function here called .text, and this text function is what will allow us to interpret the message body or the response body as plain text. So right here, you can see the raw HTML that was sent back as part of the message body. Of course, that is also wrapped in an option type. So in order to retrieve the underlying value, we would need to do a .unwrap, and that'll give us the actual value without wrapping it in the option type. All right, so that's how we can get the message body. And then we can also check for error. So we could say else if HTTP result dot is error, then we can go ahead and handle the error right down here. So we could say print line and then say error occurred. And then we'll go ahead and do a placeholder here to pretty print the error message. And then we'll just grab HTTP result dot error, and that should give us the error message. So for example, if we, let's say, plug in a DNS name that doesn't exist, like trevorsullivan.net, or maybe trevorsullivan blah blah.net. I'm pretty sure that doesn't exist, but who knows? Maybe somebody actually requested it or registered it. So as you can see right down here, it says name or service not known, failed to look up address information. So in the case that we have an invalid DNS name, we will get an error. If I try to request an invalid port, like maybe 9008, for example, that should also throw an error. So let's see what we get back this time. So it's trying to run, it's eventually going to time out and say, okay, I couldn't connect to that particular port, but that should also throw an error. So that's kind of how we can catch our errors, by checking for is error on that result and then kind of doing something intelligent with that error. All right, so this timeout is obviously pretty long here, so I'm just going to go ahead and cancel that. So we can also do things like post data. So for example, since I don't have a post endpoint available, I'm going to be using this utility here called Makun so that I can post data to a server. So what's really nice about Makun is that we can just go add a new HTTP route. We can do something like, tell it what kind of response to send right here. We can tell it what kind of method to accept. So I'll do a HTTP post here, and then I'll just call this send data. And then inside of our body, we can go ahead and post some data to this particular route. And the response could be something like response, and then say successful. So we'll just send this JSON payload back to the client. So now we're going to try to do a post operation against this send data endpoint. So what we'll do is come back in here, and we're going to use our HTTP client here, but this time we're going to send a post operation, and this is going to send data to the server. So we're going to send data to my Makun endpoint, which is running on my Windows system. So we're going to do HTTP artemis.local and then port 3000. And also, anytime that you customize the routes in here, you'll see this little button that says server needs to be restarted. So make sure that the server is running, or if you've made any changes, just click on the restart server button, and that'll make sure that these routes become available for your system. So now let's go ahead and try to do something like let post result equal the result of this post operation. And then if we want, we can actually send a body. So before we call this send method, on our request here, we get access to this builder, this request builder, and we can actually customize things like headers. We can customize the message body. We can customize all sorts of stuff on the request before we actually call the send. So in this particular case, we are going to send a body. We'll just specify a static string slice in here and see how that works. So let's do a string slice of maybe a JSON payload that says first name is Trevor, and I'll go ahead and escape these values as well. And I need to put quotes around my field value, and we'll close off the curly brace. So this should be a valid JSON payload that is interpreted by the remote endpoint. Then we'll also call .send, and then we'll do print line post result and grab the is okay. Actually, we'll just grab the .ok here because I'm going to assume that it's going to be successful in this particular case. So now let's do cargo run. And of course, I forgot to plug in my /send data endpoint right here. So let's go ahead and include that as well. And I'm going to fix the port here because it seems to be hanging otherwise. All right, so now we're calling that send data endpoint. We are doing a post operation against it, and we are including a message body. So let's do a cargo run here. As you can see, it printed the result from trevorsullivan.net, and it also gave us this option containing a response from artemis.local, which is my Windows workstation here. So the response that was sent back from the server was a JSON type here. And if we wanted to, we could go ahead and unwrap it and then grab the body text, which should also just be a JSON payload, and unwrap that. So if we try this again, we should now see response successful, which is coming back from Makun. That's the response that we hard-coded right here into the application. Now, another nice thing about Makun is not only can you mock the routes, but you can also go over to logs here, and you can see the different requests that were being sent to various endpoints. So we can see that the host here actually, or the client, I should say, sent the first name Trevor JSON payload right here as part of the body. I can also see the message headers that were included as part of the HTTP request. So having this logging functionality in Makun is really nice because I can debug any HTTP requests that were sent, as well as responses and how they're being interpreted by my Rust application. So if we wanted to, we could actually add headers. So right now we've got the accept header, content length, and host. But let's say that I wanted to plug in a custom user agent, right? Maybe I want my Rust application to be uniquely identified to a remote application so that we can determine which applications are making the most requests. Well, once again, on the method chain right here with the request builder, we can actually just continue calling more methods like .header. And if we call the .header function here on the request builder, we can specify a key and a value. So the key, of course, is going to be user-agent. That's a standard HTTP header. And then the value here, I could set to something like Trevor's Rust application on Linux. Then we can do a cargo run, send those requests again. There's our JSON response from Makun. And now if we go back to Makun and take a look at the latest log entry here, we can see that the user agent header is Trevor's Rust application on Linux. If you're on a phone, I apologize for the text being really small. This is the largest that Makun would allow me to make the text, but you'll just have to take my word for it or watch the video in 4K on your desktop. All right, so that's how we can customize some basics about these requests. We can send post requests, we can send get requests, delete requests, and so on and so forth. So one other thing that we can do is actually customize the redirect policy. If we check out the documentation here for request, let's just do a search for redirect right here. And there's actually a child module called redirect. And the redirect module contains this data structure called a policy object. Now, what we can do is construct one of these policies, and then we can use this function here called limited in order to set the maximum number of redirects. Now, by default, I think it's going to allow 10 redirects. So it says the default value will catch redirect loops, and it has a maximum of 10 redirects. So I think that that's the default value that we have when we use an HTTP client from Reqwest. But if we want to limit it to a certain number of redirects, then we can bump that number down again using this limited function right here. So let's go ahead and construct a custom policy, and then we'll assign that custom policy to a client. So what I'm going to do is go over to Mach-Kun right here, go back over to my routes section here, and I'm going to define a new route here called /weather. Okay, and the /weather route is going to redirect to another location. So we're going to do a GET request against weather, but we're going to add another route here that's called weather app. So basically, we're going to pretend that our /weather route is now defunct and it needs to redirect to /weather app. So on the /weather route, we'll go ahead and specify that the response code here needs to be an HTTP 301, which is a moved permanently. And then what we can do is go over to the headers here, and we can add the standard location header. And this allows us to determine which target location the application has moved to. So we'll say /weather_app right here. And so when the HTTP client in Rust receives this location header from the 301 response, it should attempt to redirect over to /weather app. So we'll say you've reached the updated weather app location. So this is the message that we should see if we are correctly redirected to this remote location. And then we'll take a look at how to limit the number of redirects to actually prevent the HTTP client from following that redirect that we just set up. So we're going to go ahead and restart the Mach-Kun server since we made some changes to the routes. And then we'll do an example here for redirects. So what we're going to do this time is actually use the client builder, and we are going to construct a new client. So what we're going to do is actually set the redirect policy. So the other thing we need to do is say use Reqwest, and we need to import the, what is it called? I just forgot. Redirect. And then we want the policy object right here. So we can use the policy here and say policy limited, and we could set it to, let's say, maybe 5 redirects. And then we'll say reader policy as the variable. And then we need to assign that to our client. So after we construct a new client, so we'll say let HTTP client equal client builder new. And then we should have a function on the client builder right here called redirect. So we can just chain these methods together. We call the new function, which returns a client builder, and then we call the redirect function on that client builder. And again, you can check out the documentation. So if we do a search right up here and say client builder, go to request blocking client builder, not the asynchronous one. And if we search in here for the redirect function, you can see that it's right here, and it accepts as an input a policy object. So of course, we've already constructed the policy object and stored it in this reader policy variable. So our policy is going to be reader policy. And then we'll go ahead and build the client. So we'll say .build. And now this is how we can build a custom client. Also, it's going to be wrapped in a result here. So we'll say .ok. And we'll also say unwrap so that we have access to the underlying client. So now we'll say HTTP client, and now we have access to all of these different functions here. So what I'm going to do is call a get function here against the URL artemis.local port 3000/weather, and we'll grab the result in a variable. We also need to call the send function here to send that request. And then because I'm pretty sure this is going to work, I'm not going to do any error handling here because we've already seen that. So I'm just going to say .ok and then .unwrap .text. So now that'll just grab the text result, and we'll have to unwrap that as well. So now let's say print line weather app result is debug and then HTTP result. All right, so we're constructing the policy using the limited function. We're passing in the policy using this redirect function here when we build the client. Then we call the build function to build the client, and then we OK it to get the actual result, the client object rather than the error, and then we unwrap it from the option type. Then we call the get function on the client. We call send. Then we do OK and unwrap. Then we grab the text from the response, and then we unwrap that option as well. And hopefully we should see that in here. So let's do another cargo run operation right here. And as you can see, it says weather app result, you've reached the updated weather app location. So that means that our redirect did act properly here. So the 301 on /weather, which is what we requested, as you can see right here on line 22, we requested /weather, but that ultimately redirected to /weather app, and the message body was right down here. You've reached the updated weather app location. So if we limit the number of redirects to 0, and we say, I don't want you to follow any redirects, right? Then we should receive an error in this particular case. And so what you're going to see is a panic here because we're actually getting an error, but we're not properly handling it. So what we'll do is remove this extra code over here. And after we send, we'll say if HTTP result.isError, then we're going to go ahead and print the error out right here. And we're going to pass in HTTP result dot error, and we'll close that off. And now if we do a cargo run, of course, I need to comment this out because the value gets moved after we call error here. So as you can see, it says the error is too many redirects because our redirect policy that we specified on the client is exceeded, right? We don't want it to do any redirects, and so that's preventing it from working. All right, so those are just some basics about the HTTP client Reqwest. It is a popular library, so feel free to use it, or feel free to use one of the other libraries that we talked about, like curl Rust, Hyper, which is the low-level version of Reqwest. Reqwest, of course, uses Hyper. We've got urec here as well, and so feel free to just try out any of those HTTP libraries. If you're looking for something really simple, urec might be a great option because it doesn't have an asynchronous API to it, but I have not tried that one yet myself personally. So anyway, I hope you guys enjoyed this video and learned at least one new thing. Feel free to leave a like and a comment down below. Let me know what you thought of this video, and let me know what other kind of videos you would like to see on my channel, especially around the Rust programming language. Also, don't forget to hit the subscribe button and click the bell to get notifications. Again, I'm an independent content creator, so my objective is to bring you guys useful content such as Rust programming. Thanks, and we'll see you in the next video. Take care.